I'm being asked to sketch the graph of this equation here. So the first thing I'm going to need is a set of axes. If I leave the equation in this form here, I can only actually tell two things about the curve. The first is because it's an x squared, a quadratic, I know it's going to be this sort of shape. However, I don't know where this belongs on this set of axes. If I put in x equals 0, then I get 26, and this tells me where the curve crosses the y-axis, so it's going to cross at 26. The problem is, I don't know whether the curve goes here, 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 or indeed in any other place where it crosses the y-axis at 26. The crucial thing I need to find out is where this, the turning point of the curve, actually is. I can find the turning point of the curve by completing the square on this equation. So I've got y equals x squared plus 10x plus 26, and I want to complete the square in the usual way. I get this. Now remember what I already know. I know the shape of my curve, and I know that it's going to cross the y-axis at 26. Now remember, what I'm looking for is the turning point, and that's going to be the minimum value of y. So I need to find the minimum value that this equation will take. Now, because this part here is squared, the minimum that this can be is 0, because any squared number is 0 or above. When this is 0, y will be equal to 1, so the minimum value of y is 1. I want to find out where exactly this minimum value occurs. In other words, for what value of x is it? Well, this we said was going to be 0, and this will be 0 when x is minus 5, because minus 5 plus 5 is 0. So the minimum point must be at minus 5, 1, which is here. I already know the general shape of the graph, and I know that it crosses the y-axis at 26, so now I can draw it onto my axes. This is my sketch of this graph. So, to summarise, once we've done our completing the square step, we can then find the minimum point. This value here will be the minimum value of y, and make this bracket 0 to find the value of x for which this minimum value occurs. In our example here, the turning point was at minus 5, 1. Now, here are two equations in completed square form for you. What I'd like you to do is write down the coordinates of the turning point of each of these two graphs. Press pause and have a go. When you're ready, press play. So for this one, the x-coordinate will be minus 10, and the y-coordinate will be 5. And for this one, the x-coordinate will be 7, and the y-coordinate will be 12. Now here's a sketching question for you to try. Press pause and have a go. When you're ready, press play. Your finished sketch should look something like this. You should have marked that the y-intercept occurs at 11 and that the coordinates of the turning point are 3, 2. Here's another question for you to try. Press pause and have a go at it. When you're ready for the answer, press play. Here's the answer. Now this is a more difficult type of question. In this question, I actually need to work backwards. I'm given the turning point, and I want to find out what the original equation was. Now remember, from the turning point, we can get to completed square form. The completed square form will be something like y equals x plus, let's call it p, squared, and then plus q. These might be minuses, I don't know yet. I'm going to look at this now to tell me. So I know that the minimum value of y occurs when x is minus 2. I'm going to use that to find out what p is. So if x is minus 2, and I know that this is going to be 0, p must be plus 2. Now the minimum value is 3, so I know that q must be 3. From this step now, I can actually get to this equation by multiplying out the bracket. So I get x squared plus 4x plus 4, that's from this, and then I've still got the plus 3. Simplifying now gives me x squared plus 4x plus 4 plus 3, which is plus 7. This is the equation. The value of a is the coefficient of x, and that's 4. And the value of b is the constant, and that's 7. Here's one of those for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers.